So in a conductor, you know that charges are free to move. They are freely moving because there are a lot of charge available inside that metal. For example, the metal per unit volume that is free to move. Now, the important thing that you see is how does the electric field look like when you're having a metal-like surface. When you have a metal, the charges are free to move. They can move anywhere. And when you take this plate and place it in the presence of an electric field, when you place it in the presence of an electric field, what these charges will do is they will start to move. Yeah. So what happens is, for example, this piece of metal that you see here, this is a perfect metal, a conductor, an electrical conductor. All the charges will go and align itself in a certain fashion. It will go and align itself in a certain fashion so that the electric field lines, that means the force that are experienced by unit positive charge due to this charge distribution, or in such a manner that on the surface they always make 90 degrees. They are perpendicular. So at any point you see they are always making an angle of 90 degrees regardless of that surface, as long as that material is an electrical conductor. Another important property is the electric field inside is going to be zero. The electric field inside that material is going to be zero. So that's why you can also observe that when you go into an elevator that is made up of no glass but completely fully by metal, some of the elevators are, you can see your signal reception in your phone, it will be very low. Yeah. Some of you, if you're talking on the phone, you might lose the connection because of the elevator door closing. Why is that happening? Because there is no electric field which can be inside that elevator. That means if you have a base station somewhere here, if they send an electromagnetic energy, it cannot penetrate through the elevator. And what is worse is if you are standing inside and holding your phone here, right? Your phone is transmitting something, right? This guy is not going to radiate out. What will happen is all this will get trapped inside and it is not going to have any escape. So it's going to be completely trapped inside the energy from the phone, the electromagnetic energy, and you are standing inside. So literally, you are being exposed to that very high level of electromagnetic energy. So that's why it's not very safe. If you're taking an elevator, you cut the call and then you walk into the elevator, especially if it's made of metal, so that you're not trapped inside with all the electromagnetic energy. Some of you might be using what is called as a microwave oven. This is a real application. How does a microwave oven work? For example, right? Yeah, what they do is take a so-called 2.4 gigahertz, which turns out to be the same Wi-Fi band that you use. Yeah, that particular frequency 2.4 gigahertz source is going to be placed inside the microwave oven. So if you were to take this to be the microwave oven, it is going to be somewhere here that is creating that energy and leaking into the oven. So how is the oven designed is that it's going to have this electromagnetic energy to flow inside and get trapped inside, so that you place your food there, it will absorb that electromagnetic energy. And why so that 2.4 gigahertz is so special is that there is water, 2 hydrogen atoms and 1 oxygen atom. In fact, it would be in a shape of V. And this guy resonates, yeah, like a flapping of a butterfly wing, for example, if you think, whenever there are vibrations. And when will it resonate to the maximum is when the vibration frequency is 2.4 gigahertz. And you know that when things vibrate, like you rub your surface of your hands, you're going to generate heat, isn't it? The mechanical energy gets transformed to thermal energy. The same thing happens here, where 2.4 gigahertz leads, which is electrical energy, electromagnetic energy to be precise. It leads to vibration of the H2O molecules. And as these H2O molecules start to vibrate, they will generate heat. The electromagnetic energy gets converted into heat. And that's how your food will get cooked. Imagine you have a perfect metal surface like this, right? The charges are free to move, right? The charges are free to move. Later we will see that there is something called as the potential, right? So if the charges are free to move, if I have a 1 volt potential here, the voltage is 1 volt, there is also going to be 1 volt here, and 1 volt here, and 1 volt here. There is no resistive drop along that line of wire or plate. So now, right, if there is no electric field in this direction, because there are plus charges free to align here, then if there is no electric field along the surface, then the only way the electric field can be is perpendicular. All the tangential is going to be 0. So because of that, the electric field is going to be only perpendicular, meaning that it makes 90-degree angle to the surface. So this ability for charges to freely move is called as conductivity of the material. It is denoted by is sigma. Sigma is Siemens per meter. That's the unit of conductivity. Of course, perfect conductor has infinite conductivity. A perfect conductor is like a superconductor. It has infinite conductivity. It has zero resistance. Yeah.